Imagine standing in front of your bathroom mirror, styling your hair. Suddenly, you spot it. A tiny circular patch of skin at the crown of your head, reflecting the bathroom light just a bit too well. Or maybe, you notice your hairline has quietly receded a millimeter since last summer. Your heart sinks. You immediately open your phone, search for expensive scalp oils, and curse your parents' genetics. But now, imagine you are a chimpanzee. You wake up, swing from a branch, and eat a banana. You have never bought Rogaine. You have never worried about a receding hairline. In fact, you and every other monkey in the forest will keep a full, thick head of hair until the day you die. So why did evolution, the ruthless system designed to keep us alive and well, make humans the only ape on the planet whose head can go completely naked? In the modern world, hair loss is treated like a biological tragedy. Humans spend over $8 billion every single year trying to save, regrow, or transplant their hair. We rub chemicals on our scalps, undergo painful surgeries, and wear hats in denial. From an evolutionary standpoint, this makes no sense. Natural selection is supposed to weed out traits that make us weaker or less attractive. If hair protects our heads from the elements, losing it should be a disadvantage. Yet, baldness is incredibly common, affecting up to 80% of men and 50% of women by late adulthood. How did this happen? Evolutionary biologists will tell you that baldness isn't a design flaw. It is actually a fascinating byproduct of what makes us human. To understand why, we have to look under the skin at a tiny molecular chemical reaction that is secretly running a hostile takeover on your scalp. Let's start with the biology. Every single hair on your head grows out of a tiny factory called a hair follicle. Normally, these follicles operate on a simple three-step cycle. First is the anagen phase, where the hair grows actively for 2 to 6 years. Next is the catagen phase, a short transitional stage where growth stops. Finally, there's the telogen phase where the hair rests, eventually falls out, and the factory resets to start growing a new one. It's a perfect loop. But for millions of humans, this system gets interrupted by a sneaky hormone called dihydrotestosterone, or DHT. DHT is a derivative of testosterone, the hormone responsible for muscle mass and deep voices. Think of DHT as an overzealous corporate auditor. In other parts of your body, like your face and chest, DHT walks in and says, "Great job, team, let's double production," and you grow a beard. But when DHT arrives at the follicles on the top of your scalp, it becomes a nightmare boss. It looks at the hair factories and says, "We are over budget, we need to downsize immediately." Under the influence of DHT, the follicle's active growth phase shrinks from years to months. With each new cycle, the follicle itself physically shrinks, a process scientists call miniaturization. The hair becomes thinner, shorter, and lighter until it eventually becomes vellus hair, the invisible peach fuzz you find on your nose. Eventually, the follicle shuts down entirely, boarded up like an abandoned factory in a ghost town. But here is the catch. Other primates have testosterone and they have DHT. So why don't their scalp follicles shrink and die? Why is this brutal corporate downsizing exclusive to human heads? To answer that, we have to jump in a time machine and travel back 2 million years to the African savanna. Meet our ancestor, Homo erectus. Unlike older apes, Homo erectus did something revolutionary. They started running, a lot. To survive, they became persistence hunters, chasing prey across the hot savanna for hours until the animals literally collapsed from heat exhaustion. But running under the blazing tropical sun created a massive problem: overheating. If a mammal's brain gets too hot, it suffers permanent damage. Standard apes cool down by panting, but panting is slow and inefficient when you are running. So evolution made a massive trade-off. We traded our thick protective body fur for millions of sweat glands. We became the naked, sweaty apes of the savanna, allowing us to evaporate heat faster than any other creature on Earth. But if losing fur was the goal, why didn't we go completely bald back then? Why did we keep a dense patch of thick hair on the top of our heads? The answer is simple: solar radiation. When you stand upright under the equatorial sun, the top of your head is the direct target of solar heat. Thick scalp hair acts as a natural sun hat. It traps a layer of air above your skin, preventing the sun's rays from baking your skull while allowing sweat to evaporate underneath. It was a shield for our most valuable asset, our oversized, heat-sensitive brain. So if head hair is so critical for brain protection, why would evolution create a mechanism like DHT to strip it away? Why would a hunting ancestor benefit from losing their biological sun hat? This brings us to the leading evolutionary theories of baldness. The first is a psychological reframe called the social dominance theory, proposed by evolutionary psychologist Frank Muscarella. Think about how other animals show authority. When a male chimpanzee wants to assert dominance, he stands upright and makes his hair stand on end to look bigger and more aggressive. When a male gorilla matures into a leader, the fur on his back turns silver, marking him as the dominant silverback. In humans, physical aggression is dangerous. We survived because we learned to cooperate and build complex societies. In these societies, we didn't just need young, aggressive fighters. We needed wise, stable leaders. Muscarella argued that male pattern baldness evolved as a visual signal of this transition. A thick head of hair and a heavy beard signal youth, physical strength, and high aggression. Essentially, a young warrior who might fight you. But a bald head combined with a beard creates a striking contrast. It signals that a male has matured past the aggressive, volatile stage of youth and has entered the stage of social dominance, wisdom, and resource sharing. In tests, Muscarella showed people photos of the same men with and without hair. The results were fascinating. The bald versions were rated as less physically attractive, but they were consistently rated as more intelligent, socially mature, influential, and wise. Baldness, in essence, is the human equivalent of the gorilla's silver back, a badge of peaceful authority. But there is another theory, and it involves migration. As humans moved out of Africa and into northern regions like Europe and Asia, they encountered a new enemy: lack of sunlight. We need sunlight hitting our skin to synthesize vitamin D, which is essential for strong bones and a healthy immune system. In the cold, dark north, our ancestors had to bundle up in thick animal skins, covering almost their entire bodies. Their only exposed skin was their face, and if they were bald, their scalp. Scientists suggest that older males, who were the leaders and hunters of the group, developed baldness to increase the skin's surface area exposed to the weak northern sun. A bald scalp became a solar panel, capturing vital UV rays to produce vitamin D and keep the tribe's elders healthy through long winters. But wait, you might ask, if baldness is so beneficial, why doesn't everyone go bald? And why doesn't it happen when we are teenagers? This points to a fundamental rule of evolution. Natural selection only cares about you until you reproduce. In the wild, early humans typically had children in their late teens and 20s. Male pattern baldness, however, rarely starts before the mid-20s and usually peaks in a man's 40s and 50s. By the time a man starts losing his hair, he has likely already passed his genes on to the next generation. From evolution's perspective, the job is done. The warranty on your hair has expired. Natural selection has no reason to filter out the baldness gene because it doesn't affect your ability to have children in early youth. But there's an even deeper genetic trade-off at play. The gene that makes your scalp follicles sensitive to DHT is closely linked to other biological advantages. The very same hormones, androgens like DHT, that cause hair loss are also responsible for building dense bones, strong muscles, and a robust cardiovascular system in your youth. In evolutionary biology, this is called antagonistic pleiotropy. It means a genetic trait can be highly beneficial early in life, giving you the strength to hunt and find a mate, even if it causes a nuisance later in life, like making you bald. Evolution gladly trades your hair at age 50 for muscle mass at age 20. So, the next time you look in the mirror and worry about a few lost hairs, remember this: you are not suffering from a design flaw. You are participating in a grand evolutionary legacy. Your ancestors shed their body fur so they could run down prey on the African savanna. They kept their head hair to protect their growing brains. And eventually, they developed a hormonal system that trades youth-oriented hair for signals of social maturity, wisdom, and solar-powered health. Monkeys have great hair, but they also live in trees and eat bugs. Humans built civilization, flew to the moon, and invented the mirror you are staring into. Maybe going bald is just the price we pay for being the most successful species on Earth. What do you think? Would you trade your civilized lifestyle for a full head of hair and a body covered in thick gorilla fur? Let me know in the comments below, and don't forget to like and subscribe for more evolutionary mysteries. See you next time.